All right, go ahead and pause and read the example. So example 2 says the history candidates to pass the exam, and this is from our old IB exam or textbook. A university professor determines that 80% of this year's history candidates should pass the final exam. The exam results were approximately distributed with a mean of 62 and a standard deviation of 12. So here is your mean. And we want to find the lowest necessary score to pass the exam. So 80% would be this region here. Here's your K value. And what we have to do is, in order to use our graphing calculator, you always have to go less than using your inverse norm. So we're going to be setting up an equation like this. The probability of x greater than or equal to k equaling 0.80, which is 80%. We need to subtract 80% from 100%, which is 20%. So therefore, the probability of x less than or equal to k is 20%. So we're going to be finding with our graphing calculator using inverse norm. We're going to type in the area under the curve, 20%, then the mean, then the standard deviation. And what you should get is a value as such, 51.9. So that's your K value. So what that means, we'd want to round it up to 52. So the minimum to pass the class would be a score of 52 on the final exam. Here's another example. So the mass of coffee grounds in Caribou coffee bags is normally distributed with a mean of 5 grams and a standard deviation of 0.1 grams. It is known that 25% of the coffee bags weigh less than C grams. Find C. So let's say here is our 25%. And here's our C value. And we want to find out what that C value is. So we're going to use our inverse norm, and we're going to type in the area under the curve as a decimal, so 0.25, the mean of 5 grams, and the standard deviation of 1 gram. And when we're done, we would get a value of 4.93 grams. So what that means is about 25% of those coffee bags will weigh less than 4.93 grams.